Hello everyone. In this video I'm going to talk about mathematical groups, how to define them, what makes a mathematical group, and the principles that makes a group, and some mathematical signs as well. The first principle that defines a group is closure, and what that means is if you define a rule for that group, for instance, that rule should be maybe multiplication. And a set you have is A is equal to even numbers 2, 4, 6, and so on. The rule is all the elements A multiplied by B should be as well in set A. In that sense, 2.2 times 4 is also even, so it makes one of the criteria fulfilled. But if the rule was addition, and A would be 1, 2, 3, and 4. In that case, you should notice after, for instance, adding 1 to 4, it is not in that set anymore. So because the set is close to 4, it wouldn't be inside the set A. So the set 1 to 4 for plus rule wouldn't be a group. The next rule is associativity. You already have learned it in a school, and it is nothing more than if I multiply A by element B and then by some element C, let's say by number 2, it should be equal to as you multiplied A times C and then by B, or whatever elements you take it out and multiply by that one. Neutral element. Neutral element or neutral element means actually whatever the rule is. For instance, the rule is addition. If the rule was addition, if you add a number to it or subtract it, it wouldn't change anything. For instance, 0 is a good example. 1 plus 0 is already 1. Nothing has changed. And if the rule is multiplication, then 1 is neutral element. Neutral element or neutral element, you will always show it by E. So 5 times E should be already 5. Nothing has changed. But if I have a set that is, let's say, 1, 2, 3, is that a group or not? These are important. You will be using these rules, so I do not mention right now, but these are important. Is that a group or not? I do not find, if the rule is multiplication, yes, that the criteria of neutral element is already fulfilled. But if the rule was addition, I do not have 0 here. So set A in this case is not a group if the rule was addition. Now we have inverse element. What is inverse element? If I have element A, depending on the rule, let's say the rule is addition. And if I add that to A, and if the rule is addition, A plus that neutral element, let's call it N, NE, should give me neutral element, inverse, I'm sorry, this is inverse element, plus inverse element should give me neutral element. And you remember for addition, the neutral element was 0, so A plus whatever should give me 0. Yes, that should be minus A. For instance, as an example, 4 minus 4 minus 4, 4 would be inverse element if the rule was addition. But what if my set is A is equal to minus 2, minus 3, minus 1, 0, 1, 2, and 3. For 3, as you can see, there is no neutral element here. So for addition, for 3, no inverse element was found. If the rule is multiplication, as you can see, the inverse, the inverse is nothing more than the vice versa. So 4 multiplied by inverse should give me E, and for multiplication, you remember E is 1. So 4 multiplied by whatever 1/4 would give me 1. And again, in a set that is, let's say, 1/4, 1/3, 1/2, 1, and then 2, 3, and 4, and 5. Again, this cannot be grouped because there is no 1/5 to counterpart 5th, 1/5. Now you definitely know, if you are reading this in your textbook, it is not written in this language, and there are some alien signs that we have to decipher. First, I want you to learn an upside down A, and this means for all or for every. And then we have an inverse E, which means exists. There you already can say all and A. There is an A here and there is an all here, so you can remember it. They could already also use some sign like this, but you know they are mathematicians and their goal was to make your life miserable. And this is E for exists. Also they could write something like this, but you know they are mathematicians. Now let us interpret the rules or axioms we already have mentioned with these new tools, and say the closure. The first rule was if A and B multiplied by each other, they also should be included in set A as well, so we can call it a group. So for all elements of A and B which belong to set A, there exists with there exists it would be a little bit more complicated, so we can say A and, you show and with comma here, A multiplied by B also should be in A. Just like even numbers, if you multiply even numbers to each other, you would get also even numbers. The second rule was associativity, so you can call it, and it means if you have elements A, B, and C, so for all elements A, B, and C which belong to set A, the rule is, I'm sorry, there is no parenthesis here, my bad. It is not very common here to use parentheses. And C. There exists A multiplied by B, so you have the rule here should be equal to A multiplied by C and then multiplied by B. The third rule, inverse neutral element, neutral element means for every element A there exists an element E which such that, or you can show it with a pipe as well, such that A and neutral element E belong to set A, and A multiplied by E should give you A, or and finally, for the last rule, or inverse element, you say for all elements A there exists an inverse element. You can also show it with B, such a way that A multiplied by inverse would give you a neutral element, or A multiplied by, let's say, 1A would give you 1. Or if the rule is addition, it would be A plus a minus A would give you a 0. Thank you very much. That was about inverse element, neutral element, and mathematical groups. Have a nice day, have a nice night. Bye.